What if I told you that time isn't what you think it is? That black holes can vanish into nothing? That our universe might be just one of many, hidden inside extra dimensions we can't even see? Sounds like science fiction, right? Well, it's actually the cutting-edge physics explained by none other than Stephen Hawking. Welcome to my channel. Today, we're diving into the universe in a nutshell, where Hawking unpacks the biggest mysteries of time, space, and reality itself. So, if you've ever wondered about time travel, black holes, or the fate of the universe, stick around, because this will change the way you see everything. Before we begin, don't forget to subscribe for more fascinating deep dives into the mysteries of existence. Now, let's unravel the secrets of the universe. Einstein's legacy and the theory of relativity. To understand modern physics, we need to go back to Albert Einstein. Hawking starts by explaining how Einstein's theory of relativity changed everything. Before Einstein, people thought time and space were absolute, like a giant stage where everything happened in a fixed way. But Einstein came along and said, nope, time and space are flexible. They can bend, stretch, and even warp depending on gravity and motion. This was groundbreaking because it meant that time isn't the same for everyone. A clock on a spaceship traveling at near light speed ticks slower than a clock on Earth. And gravity? It literally bends space and time around massive objects, like planets, stars, and black holes. That's why GPS satellites have to correct for time dilation, or else your Google Maps would send you into a river instead of your destination. Quantum mechanics, the strange world of the tiny. But while Einstein's relativity explains big things, like planets, galaxies, and black holes, there's another side to physics, quantum mechanics, which governs the microscopic world of atoms and subatomic particles. Here's where things get weird. In quantum mechanics, particles don't just sit in one place. They exist in multiple states at once until someone observes them. Yes, reality itself depends on whether someone is watching. That's why we have Schrödinger's cat, a famous thought experiment where a cat in a box can be both alive and dead until you check. Einstein wasn't a fan of this randomness. He famously said, "God does not play dice with the universe." But quantum mechanics says otherwise. Particles do behave randomly, and this uncertainty is at the heart of reality. The grand struggle, unifying physics. Now, here's the big problem. Einstein's relativity and quantum mechanics don't get along. It's like trying to mix oil and water. Relativity explains the vast universe, while quantum mechanics explains the tiny world, but when you try to combine them, boom! The math breaks down. Physicists have spent decades searching for a theory that unites them, often called the theory of everything. And that's where string theory and M theory come in. M theory, the multi-dimensional universe. Hawking was a strong supporter of M theory, which suggests that everything in the universe is made up of tiny, vibrating strings. But here's the kicker. These strings need more than just 3 dimensions of space and 1 of time. According to M theory, the universe has 11 dimensions. We just can't see the extra ones because they're curled up, smaller than an atom. These extra dimensions could explain why gravity is so weak compared to other forces. Maybe it's leaking into these hidden dimensions. And if M theory is right, our universe might just be one of many in a vast multiverse. Black holes. Portals to the unknown? Of course, no Hawking lecture would be complete without black holes. These cosmic monsters are formed when a massive star collapses under its own gravity, creating a region of space where nothing, not even light, can escape. But here's where things get wild. Hawking discovered that black holes aren't completely black. They actually emit tiny amounts of radiation, now known as Hawking radiation. Over time, they slowly evaporate. This was a mind-blowing discovery because it means black holes can die, shrinking and eventually disappearing. Even crazier, some physicists believe black holes might be gateways to other universes. If you fall into one, you might not just be crushed. You could pop out somewhere else entirely. But, I wouldn't recommend trying. Time travel. Is it possible? And now, the question we've all been waiting for. Can we time travel? According to Hawking, time travel might be possible, but there are some serious problems. One way would be to travel near the speed of light. Remember how time slows down for fast-moving objects? If you flew in a spaceship at near light speed for a few years, you'd return to Earth to find that decades had passed. That's real, proven physics. Another method? Wormholes, hypothetical tunnels through space-time. If you could stabilize one, you might create a shortcut between 2 points in the universe, or even travel to the past. But don't get too excited. Hawking believed nature has a way of preventing paradoxes like the classic grandfather paradox, where you travel back in time and accidentally stop your grandparents from meeting. No grandparents, no you. No you, no time travel. So, while time travel sounds fun, the universe might have built-in rules that stop us from messing with the timeline. The future of the universe. So where is all of this leading? Hawking believed that the future of the universe depends on dark matter and dark energy, mysterious forces that make up most of the cosmos. If dark energy keeps expanding the universe forever, we might end up in a big freeze where everything drifts apart into cold emptiness. But there's also a chance the universe could collapse in a big crunch, reversing the expansion and crushing everything back into a tiny point, maybe even starting a new Big Bang. Or maybe something even stranger will happen. After all, the universe still holds more mysteries than answers. Hawking's The Universe. In a nutshell, isn't just about physics. It's about curiosity. It's about pushing the boundaries of what we know and daring to ask the biggest questions. Are we alone in the universe? What's beyond our cosmic horizon? And will we ever truly understand the fabric of reality? One thing's for sure, Stephen Hawking's ideas continue to inspire scientists, thinkers, and dreamers. He showed us that even in the face of immense challenges, the pursuit of knowledge is limitless. And that's our nutshell summary of The Universe in a Nutshell. If you enjoyed this mind-bending journey, hit that like button and subscribe for more fascinating insights into the mysteries of the cosmos. Thanks for watching, and until next time, stay curious.